Okay, in this video, we're going to take just a couple of minutes really and derive an expression for the inverse hyperbolic tangent function of x. And again, we'll derive it in logarithmic form. Just to remind you that if I have this inverse hyperbolic function of x and I set that equal to y, that's the same thing then as saying that the hyperbolic tangent of y equals x. And what you see on the right over here, this curve is the hyperbolic tangent function. This is the inverse hyperbolic tangent function. And for the range here, x is less than 1 or it's greater than -1. Or we can sum these together by saying that the absolute value of x is less than 1. Okay, we proceed just like we have been doing. We start with this expression here, which will give us e to the y minus e to the minus y divided by e to the y plus e to the minus y, the hyperbolic sine over the hyperbolic cosine, and that is equal to x. And let's multiply through by this, so we have e to the y minus e to the minus y will equal x e to the y plus x e to the minus y. And let's put the positive exponents and the negative exponents, collect them so they're on the same side. So here we'll have x, we'll have e to the y minus x e to the y will equal x times e to the minus y plus e to the minus y. And we'll factor this out, so e to the y times 1 minus x equals e to the minus y times 1 plus x. Now let's divide both sides of the equation by this. So e to the y divided by e to the minus y, and this would just be e to the plus 2y. This divided by this, e to the plus 2y, and that will equal this divided by this. E to the 2y equals this, so if we take a logarithm of both sides, then we're going to have that 2y is equal to the natural log of 1 plus x divided by 1 minus x. And that's it. There's no quadratic formula involved because there's no quadratic expression. So we only get one value for each of the 2y. And so we're only going to get one value for y, and that would be this. Or that would equal the natural log of 1 plus x divided by 1 minus x to the 1/2 power, or we can write it like the natural log of 1 plus x divided by 1 minus x, and we're taking the square root of that. But that's it. There's no more to it than that. That's what y is equal to. But y itself can be the inverse hyperbolic tangent of x. So this equals, give ourselves some room here, natural log of the square root of 1 plus x divided by 1 minus x. And as you can see, it's a very straightforward thing to derive. If you first looked at it from here, it may not have been apparent at all that the inverse hyperbolic tangent can take on this logarithmic form. But if we start with this definition and just work our way through, then it falls right into place. Now down here in the denominator we have 1 minus x. We have to be careful that the denominator doesn't blow up on us. But x, remember, is restricted to these values here, so that doesn't pose a problem for us. So we're okay with that. The only other comment we would make then, if indeed this is true, is that if we take the tangent of both, the hyperbolic tangent of both sides here, we would say that x equals the hyperbolic tangent of this expression here, the natural log of the square root of 1 plus x divided by 1 minus x. So if indeed this is true, then if we take the hyperbolic tangent of this function here, that should simply be x. And it might take a while to grind through all of that. We probably won't have time to check it out in this video, but come back and join us for the next video when we will go through that exercise and then see if indeed that does give us x. Okay, that's it for this video. Come back and join us for some others, and we're still going to continue talking about inverse hyperbolic functions, expressing them in logarithmic form, and then later on we'll also take the derivatives of the inverse hyperbolic functions.